Hello everyone, welcome back to my YouTube channel. In this video, we shall discuss on the statistical analysis by using t-test. A researcher measures the concentration of caffeine in milligram per liter in 12 samples of brewed coffee after a standardized brewing process. The caffeine concentration are as follows. By employing the t-table, determine the margin of error of the data set with 95% confidence interval. Right, so to answer this question, the first thing that you need to do is you need to find what is the mean of the values. So the mean or the average is the summation of all the data points divided by the number of sample, which is 12. So in saying that is 68.0 plus 70.2 plus 65.4, so on and so forth, divided by 12. So you will get 829.9 divided by 12, therefore your mean shall be 69.1583. So this is the first step that you need to do in order to answer this question. Alright, so the next step is you need to find what is the standard deviation. So for the standard deviation, the first thing you need to do is you need to know what is the summation of all these values, and then you need to minus with your value of mean, and you need to do a square of that. So for instance, we can say that is 68.0 minus your mean, which is 69.1583, the one that we have calculated just now, square, plus 70.2 minus the mean again, 69.1583 square, plus 65.4 minus 69.1583 square, plus 72.5 minus 69.1583 square, plus so on and so forth. So you get the summation of this, which is going to be 61.3091. So this is the second step. Then only you can proceed with the calculation of the standard deviation. So for the standard deviation, the value that you have calculated just now, 61.3091 divided by the number of sample minus 1. So all this number you need to square root it. So it's going to be square root of 5.5731. So you will get your standard deviation equivalent to 2.3607. So this is your standard deviation. Alright, so now we are looking at the question. It asks you to use the t-table. So it means that you need to find the margin of error. So the margin of error is equivalent to T alpha divided by 2 degree of freedom times standard deviation divided by square root of n, which is the number of sample. So what is alpha? So the alpha is 1 minus confidence interval. So in this case, what we can say that your t is going to be alpha 1 minus, because this is 95%, so 95%, so 95 divided by 100, so it's going to be 0.95 divided by 2, and then your degree of freedom is going to be the sample size, which is the n, minus 1, so times your standard deviation square root of n, so your n is actually equivalent to 12. So This one we need to calculate first. So your T shall be 0.025. So this one is 12 minus 1 is going to be 11. And your standard deviation is the value that you have calculated just now, 2.3607 divided by the square root of 12. Alright, so from this calculation we know that your T is 0.025 and your degree of freedom is 11. So degree of freedom 11 and your T is 0.025. So degree of freedom is 11, so it's around here 11, and 0.025 is here, so you need to go down and read. So you should get this value is actually equivalent to 2.201. So you need to times this value 6.8148 times 10 to the power of negative 1. So you will get 1.4999. Right, so this is the margin of error and the final answer for this question. Alright, so next up you were asked to calculate the confidence level of the data set with 95% confidence limit. Alright, so the formula for confidence level is equivalent to plus minus T times standard deviation divided by the N. So the T is the one that we have calculated just now from the table, referring to the table. We will get our T is equivalent to 2.201 and the standard deviation that we have calculated is 2.3607 divided by square root of n. N is the number of sample, which is 12. So you will get your confidence level is equivalent to 2.201 times 0.6815. Therefore, you will get your final answer equivalent to 1.4999 as well. Thank you so much for watching this video from the beginning till the end. So I'll see you again in the next video. Goodbye.